Hello students, welcome to the next session in the distributed systems where we are going to deal with the emerging trends of the distributed systems. See here, we are going to deal with few topics which are trends nowadays. So those are grid computing, cloud computing and self-management. Along with that, how virtualization will be maintained in the distributed system, and SOS, service-oriented architectures, and few future emerging trends. Now, the latest trends, why we are having this latest trends means there are several reasons for that, right? We have performance optimization. See, already if we have an existing system with few features, and now why we are moving to the proposed system is a case here. Now, when we have few systems, why these are called as emerging trends is a point. So when we are dealing with this enhanced versions of the topics, there may be few reasons, right? So the few reasons we are going to list here. Performance optimization. So efficiently and reliably, if we are getting any data, request and response, or else if the system is reacting within a fraction of minutes. So all this comes under the performance optimizations. Next, security enhancements. So coming to the security enhancements, here we are going to know about how the protocols or how we are setting the protection to a particular n number of systems in the distributed environments. All these security measures which are taking place, due to that reason these are called as a few. Next, whatever we are about to deal, so those are called as emerging trends. Now, cost efficiency, obviously if the systems are open source, okay, that will be a good thing, but if the protocols or if the standards, if our systems, whatever we are utilizing are cost effective, means again that will be a problem. So cost efficiency wise we have to take care. Next, competitive edge. So on the competitive edge means what, maybe the cutting edge at that moment. So nowadays if we are dealing with the AI, so that is a cutting edge with the neural and CNN, RNN and next deep learning. So all these are the trends which we are going at this moment now. Next, adaptability is nothing but technology wise or the language wise, configurations wise. If any system is about to adopt anything from other systems also, that would be a good thing to a number of concepts. Now, the topics which we are mentioning as an emerging trend is a cloud computing. So cloud computing is nothing but we are going to maintain data through the internet. Okay, so if I have as a person of one hospital organization, if I want all my patients call sheets or records, we can say, so all the thousands of patients records, if I want to be stored at one place, my system will not be sufficient for that. So what I will be doing is I will be taking the license to a storage as a service, we say that. So cloud computing can be deal with n number of services like platform as a service, infrastructure as a, I can buy the infrastructure for some days, I can lease, I can take it to lease for some days, and then after my utilization that license will be cancelled over there. Like that I can take some storage, I can store all the data over there, and I will be paying for yearly, annually, I can pay so and so dollars. So all these kinds are very, very important in the cloud computing, and cloud computing is providing such kind of services to us. So that is a very important reason where we need cloud computing as an emerging trend. And we have few services these are the basic services, we can say: scalable infrastructure, load balancing and the data replication. So load balancing wise, cloud services can distributively work on it in the traffic way to concentrate on the incoming and outgoing messages or the services, we can say. Data replication, cloud will be having a number of solutions where we are going to have all the nodes or the locations where my exact data will be available. I'll be giving that link to my clients over there. Next is the grid computing. See, grid computing is also one of the emerging because it have a capacity to perform a task with where the system is only single machine. Like we will be thinking that is the only single machine and working on the single configurations, but a number of systems will be working internally. So network of computers working together network of different computers working together to perform one task. And coming to the configurations wise, n number of systems may be different configured. So this grid computing is very, very important to have different types of objects, different types of configurations to club, to encapsulate together to perform one task is done by the grid computing. So this is also one of the main important, and this has a capacity to work as a virtual supercomputer also, because supercomputer will have all the permissions, all the accesses, all the different kinds of data it can hold, it can give. So all that can be possible with the grid computing environment. We can have CPU overloads, of course, but we are going to maintain that in the parallel computing, right? So when we say parallel computing, at that moment, if I have a task of 10 GB, 1 GB, 1 GB, I'll be giving to a number of users. So all the users will be computing parallelly at that moment. And these are the few features we can say, the services which are given by the grid computing. Scalability wise, it is very strong because the name itself, grid, means it can hold anything, right? So scalability means dynamically it can add a number of systems, it can remove a number of systems, all those can be done, adding, deletion, manipulations, everything. Resource utilization will be done very efficiently in the grid computing, because this is a pool of resources where different systems will be there for the maximum computizations over there. Next, complex problem solving. Yes, of course, because as it can hold large scale systems, we can go with the complex problems analysis also. Collaboration, the name itself, grid, means it's a collaboration of a number of geographical systems over there. There is no system configuration, you can't come into my network kind of thing in the grid computing. Cost savings, okay, this is a limited one where we are going to access the computers, or else when we are accessing cloud data kind of things, at that moment it will be costing high. Other than that, it is okay. Now the next one is a virtualization. See, in the virtualization, the name itself is saying that virtualization, all the physical resources we are making into the logical view, that is nothing but the virtual view. These kind of things are very important because we will be having n number of replications. I have only one resource, so I am making a replica, I am in the virtual of my resource to be available to all the systems. So this is a one of the architecture where every host machine will be having internally hardware, on that will be having the operating system, on that the user level will be there. But coming to the virtual machine system, you will be having hardware and then the virtual monitoring system, and then on that you will be having the operating system, then the user applications. So coming to the advantages, these are more flexible, low cost, and we can pay cost as per the usage whatever we are maintaining, and multiple OS can also be running at the means if I have Windows, I can go with the virtual Ubuntu, right? So in the similar way, we can go with the multiple OS as a virtual thing. And coming to the types, I have application, means I can make my overall application itself as one of the virtual entity over there. Network means I can run virtual network. We have VPNs to act as a virtual networks over there. Desktop means my total operating system environment I can make available as a remote thing. Storage means servers I can maintain as a replica, means as a virtual thing to be available to the other systems. Now coming to the self-management. See, self-management is very simple. Already we have discussed in the 1.3. If you have any doubts in this, you just go to that 1.3 once again. See, this is nothing but every system will be having the capability, resilience, fault tolerance we can say, have the capacity to work on itself automatically. If a system is having adaptable configurations, immediately it will be making itself to adaptable to that configuration, self-configuration, self-managing, self-healing, means if any attacks or anything happens, recovery procedures can be done immediately itself, that is called as self-healing. Self-optimization means when we have a number of loads happening, so we have to reduce that load balancing and everything can be done. So these all under self-managing systems. Next is the SOA. SOA is one of the service-oriented architecture where it has it can go with a number of application development integrations. So if we have one existing system with us, and depending on the existing system, I can go with the one proposed system, right? So instead of that, I will be utilizing this existing system overallly, and then I can reuse that, and then I can go with the new version over there. So there, this is totally different from the microservice. So next is nothing but this SOA has a number of users to work on the existing services to perform new applications. Next, it has a number of design principles to work on the both coherent and decentralized systems also. Next, SOA based computing packages. See, functionality wise also, I can take the interoperable service. So interoperable is nothing but we can accept different kinds of objects into one system. So that is what is a interoperable services. Now the characteristics already we have seen. Interoperability, of course, that will be there for sure. Next, encapsulation, service recovery, compositions, reusability. Next, quality wise also, quality of services also it can provide to us. Next, loosely coupled services, there is no restriction that you must utilize this one only. Next, location transparency, where we have that particular object, we will be having that all the scalability, and we can add new systems and all. Next, ease of maintenance. Now SOA has a capacity to perform two roles, that is the service provider, also the service consumer. Few moments it will be acting as a service provider to all the services, remaining services. Sometimes it will take services from the existing one. Now the future trends in the distributed systems may be ubiquitous edge computing. So ubiquitous itself is which are dependent on the edge, cutting edge. So we have AI integration over there, and smart infrastructure means IoT based, sensor based, and we have management, self-management kind of things. Next, security wise, if we can reach quantum cryptography, advanced quantum cryptography, zero trust means that is a good thing. Next, quantum computing, obviously integration of the quantum computing to perform high computational systems. Next, quantum network, interoperability. Interoperability is also, I have said, performing different configured systems in club into one and make your system to work on. So that is nothing but cross domains into one category, we say. Next, open standards and API. So all these are coming under future trends which we can work as a research areas. If you have interest, you can go for that. And this is the end of this session. If you have any doubts, please be free to contact anytime in the college. Thank you.